Okay, so can you hear me?
Yes, sir.
Okay, just waiting some minutes, then we'll start. Okay, so we'll start now. Okay, so basically today is our fifth number test. And mainly today's session, I try to explain about that air quality monitoring, how we can easily monitor the air quality different types of parameter using Google Earth Engine or remote sensing or GIS technologies. I will try to explain about that. So let me share my screen. Okay, can you see my screen? Is it visible? Okay, thank. So basically today's session, I try to explain about that fifth number test for air quality monitoring using remote sensing technique. Okay. So this topic I try to complete all of content. So first of all, we try to discuss about that air quality monitoring, all parameters. So different types of air quality parameters such as nitrogen oxide, sulfur dioxide, carbon monoxide, or methane, okay, or aerosol. So these type of things I will try to explain about that, how we can easily monitor or how we can easily trace this type of gases. We also explain about that. Then how to download the air quality parameters time series data in CSV file format. We also discuss about that. And how to make the air quality monitoring time series chart. We also discuss about that. And how to calculate the total emission for any specific gases. It can be nitrogen dioxide or sulfur dioxide or any specific gases, how we can easily calculate the total emission for a specific time period. As well, I also discuss about the AOD, mainly aerosol optical depth, how we can easily monitor, or PM 2.5, mainly particulate matter 2.5, how we can easily monitor. And we also discuss about the ArcGIS, mainly ArcMap tool, how we can easily use and make the map proper map. And also discuss about the accuracy assessment of your air quality monitoring map. Okay, what is the accuracy? So basically, when you want to work with for accuracy, you also need the ground truth data. So I will try to explain all of topic one by one. I hope we can easily get the idea how we can work. So let me open my slide. So first of all, here you can see this is the example about the two map. One is the methane concentration map of Kuwait, and another one is the nitrogen dioxide concentration year of 2020 month of January. So we can get this type of result. One is the methane. This unit is the ppb, mainly parts per billion. Another unit is the mole per meter square. Okay. So we can easily convert the different types of unit, as well as we can also make this type of map. So basically this analysis we did using Google Earth Engine, and further we simply download the data as a GeoTIFF file format, and further creating the map layout we are just using at the ArcMap tool and create this type of map layout. So today's session is also showing this part how we can easily create this type of map. Also you can see this is the nitrogen dioxide level rebound for the different time period, and we also make the classification, okay, for before lockdown, during lockdown, and post lockdown. So it's one kind of our project. So we try to find out the classification, mainly very low, low, medium, high, and very high distribution of nitrogen dioxide for the different time period. So these type of things we can easily do using Google Earth Engine, and further we simply export the data as a GeoTIFF file format, and further analysis we are just use at the ArcMap tool to creating this type of layout view. So now we discuss about the air quality monitoring. So basically in this case, where you can easily get the different types of satellite for different air quality parameters data. So one is the very most popular data set is the Sentinel-5. Okay, from the Sentinel-5 P data, mainly it's the tropospheric monitoring instrument. So using this data, we can easily trace the lot of air quality parameters such as ozone, nitrogen dioxide, sulfur dioxide, aerosol, carbon monoxide, methane. So all of gases we can easily access from this Sentinel-5P tropomi. And this is the dataset link. So you can simply visit the link, then you can easily get all of dataset. Or if you want, you can simply go to the code editor. Suppose I'll show the example. Just simply go to the code editor. From this code editor, we can easily also access the dataset. Just click on here. Just open the code editor. And in this code editor, we can easily get the Earth Engine data catalog. And from the Earth Engine data catalog, we can easily get all of dataset for Sentinel, Landsat, every dataset. Just click on the browse data catalog. So here you can see the Sentinel. Just click on the Sentinel. So here you find out the data agency Sentinel-5P, mainly tropomi, tropospheric monitoring instrument. Just click on here. So now it provides all of data. Here you can see for the aerosol index, UV aerosol index, also cloud. You can see the carbon monoxide. Okay. Also you can see the formaldehyde data set. Also you can see the ozone. Okay, ozone data set we can also get. Also nitrogen dioxide we can also get. Also you can see about that the sulfur dioxide we can also get. Methane we also get about the methane. Okay, so now this type of data we can easily access from the Sentinel-5P satellite imagery. So all of dataset are the similar process when you filtering or when you creating the mapping. So I will show you the one data. Suppose I want to show the data for sulfur dioxide, how we can work with that. Or also you can see the methane. Suppose I want to show you for the methane. Just click on the, you can see we find out the two types data. One is the offline, another is the near real time. But methane is only offline data set is available. So for more real time data is not available only for the methane, but all of other data set you can see we find out the offline and near real time, offline and real time, mainly NRT, near real time, NRT. Also you can see about that all of data set provide the NRT, but only for the methane are not available for the NRT. It's just about the offline data. But this type of data we also get the very update information, very recent data we can easily get. Okay, so suppose I click on here, you can see near real time for the sulfur dioxide. So we find out the data, you can see 29 November, okay, 2024. So 29 November we find out from the NRT, NRT, okay, mainly near real time sulfur dioxide. And this is the last update time period 2024, 29 November NRT data for sulfur dioxide. So if I check for the offline, suppose just click on the offline, so then we also get the data for this time. You can see 27 November. Okay, so sometime we need the near real time analysis, then use here the NRT. Sometime we need the not near real time for the past data we want to analysis, then you also try to use here the offline sulfur dioxide. So all of data for the sulfur dioxide, also you can see the ozone, nitrogen dioxide, formaldehyde, carbon monoxide, we find out the offline and near real time. So near real time is very recent data. We find out the very recent data from the near real time. But offline, it not provide the more recent data. Okay, for that, not up for the previous 2 or 3 days data, we can easily get from the offline. So that's why when you want to work with the mainly real time or the present time, you want to monitor, then you use the near real time. But when you want to work for the past time data, then you try to use the offline. Okay. So now I want to work for suppose methane. Just I click on the methane. So now I can get this type of information here. You can see the offline methane. This data set availability time. We got the data from year of 2019, 8 February from 26 November 2024. Okay, this is the last update time for this data set. And this dataset provided is the European Union, yes, Copernicus. And here we find out this type of information. Here you can see, we find out that this resolution is that 1113.2 meter. This is the resolution or pixel size. Pixel size 1113.2 meter. We also get here, you can see the first band is that methane column volume mixing ratio dry air. So this is the column average dry mixing ratio of the methane as parts per billion. Okay, parts per billion, mainly ppb. Okay, so basically when you want to work with this band, so this unit will be ppb, mainly parts per billion. We get the result in parts per billion. Further I will show you that how we can easily convert the unit. So this is the data for parts per billion. Okay, also you can see we can get the aerosol height. So this is the another band. Unit is the meter, m for meter. So aerosol height parameter in the methane retrieval. Okay, how much height it retrieval, we can easily get the information from aerosol height, as well as also aerosol optical depth, sensor azimuth angle, sensor zenith angle, solar azimuth angle. Okay, so different types we can see. Also you can see the methane column volume mixing ratio drive bias corrected. So this is the another. Okay, and it's also calculated as parts per billion, mainly ppb. So we find out the different types of band about this data. I'll also check the description. So basically, in the description, they are mention the information, how they get the data, how they filtering the data. So everything will be including in this information. So basically, here you can see that right methane is after carbon dioxide. This is the most important contributor to anthropogenically enhanced greenhouse effect. Okay, after the carbon dioxide, one of the most important contributor is the methane, okay, to anthropogenic enhanced greenhouse effect. And roughly three quarters of the methane emission are anthropogenic, such as important, okay, record satellite based measurement. Tropomi aims to providing the nitrogen column number concentration with high sensitive to the earth surface. Okay, so you can easily get, also get the more information, then you also get the more better information about that. And how they filtering the data, okay, how they mainly remove all of unnecessary pixel. So every information you can easily get from here, okay, how they create the product, everything including in this here. So now I want to use this data, and further I want to monitor the methane concentration for any specific region, as well as I also want to make the time series chart or everything I want to do it. So for doing these things, first of all, just copy this snippet because this is the unique ID about this data set. Just copy and then paste. Paste. Just let me increasing the code editor. So just I simply import my study area. And now I want to just take a variable. Suppose data set. Okay. So now I simply import my data set. So this data set, including the information offline methane, okay, between this time period 2019 to 2024. But I want to observe for a specific time, for a specific month, or a specific year. So you can easily filter your time period. So just use here the filter date function. We already know about that. Just put here the filter date, and put the specific time period when you want to filter your data set. So you can put any time period, which time you need. So I simply put the time period, suppose year of 2024, 1st January, from year of 2024, suppose February 28. I put this type of time. And further, you also select the specific band. Okay, so here you can see it provide the specific band look like that. So for the different purpose, we're using the different types of band. Suppose in this case I want to calculate the average dry air mixing ratio of methane. Okay, so average concentration of methane. So for that I have to use this band. Just copy the band name and then select and paste here. Okay, so first of all, simply import the image collection, then filter the specific time when you need. Sometime you need the specific month. Suppose I need the month of January, month of February, or any specific year, or summer season, rainy season. Just simply put your own time period, and then further simply select your specific band. Okay, so in this case I want to calculate the average concentration of methane. So that's why I simply set this band. So now if I check how much images are available in here, so just print and call this data set and use that the size function. So now it's computing how much images are available for this time. To run it, we find out, you can see how much image we find out the 817 images are available for my data set. In this data set, total 817 images is available. So now further, you also need to import your study area. Suppose you can simply import your own study area, which area you want to work. So simply import your shape file, as well as if you want, you can simply put here the DOS dataset. Basically, this is the one kind of dataset. It provides you the international country boundary polygon. So you simply search, just import this dataset, and further filter your specific country. Okay, so I already discussed a lot of time about this data for US data set. Basically, it's provide the international country boundary polygon. Just take a variable, suppose RY, and now I want to filter. I want to filter this table because table, this is my variable. This variable stored all of international country boundary polygon. So just I try to filtering. Just call the table and then filter. I set a filter, then I define how I can filter. I want to use filter equal. So now put here the suppose country name, and also put here the country name. Suppose I put here the country name is that United States. Okay. You can put any country name, then we can easily get any country boundary shape file. So I put the United States, so we can get the United States country boundary polygon. And this polygon is stored in the ROI. So if I display the layer, suppose just use here map.add layer and call the ROI and click to the run. So now we find out this type of polygon. Okay, so I want to need the result for this polygon. So just I simply import my study area, and now I have already get my image collection for a specific time. Okay, 817. So now I want to reduce this image collection. Suppose I want to calculate the average concentration of methane, average concentration of the methane for this time, year of 2014, January to February. So for that, just take a variable. Suppose I put the variable name is the suppose mean CS4 equal. I just call the data set and then I apply the reduce. Reduce is one kind of statistical function. So just I apply the reduce, then I need to define how I can reduce. I want to calculate the average pixel all of images. So put here user ee dot reducer dot mean. Okay, and further these things I want to clip with my study area, which is ROI. So now check the result. So just add here map dot add layer and call the mean CS4 and click the run. So now it's computed the average concentration of methane. So here you can got this type of result. Okay, show that the white color. Okay, but further if you want you can also add the color. So for adding the color in the Google Earth Engine data catalog page for these things, we can easily get some color here. You can see. So just I copy this color code from here, and this color code I want to add in my code. Just paste here. Okay. So in the color code, mainly they are make a dictionary. In this dictionary, they are put at the mean value and max value. Basically, this unit is the ppb, mainly parts per billion. So just I copy these things and then paste here, and I put it. It's a suppose CS4 layer. I put the layer name. You can put any name. So now click the run. So now this color is set in your map, and we find out the colorful map. So now it look like that. We find out this colorful map look like that. So here mainly red color is indicating about that high concentration of methane. Okay. So if you want, you can also get the more better result. Suppose just click on here and stress the data. So just I apply the stressing. Suppose stressing 98%. And further apply. So now if I also look more better visualization. So now you can see you can get this type of result. So this type of red color indicating about the high temperature. It's including about the high temperature, mainly high concentration of the methane. We find out the high temperature of the methane for this type of red color. So here you can see, and some place is not showing the pixel value. It means that for this place there are not any kinds of value for methane. Okay, and we find out this type of map for my unit data set. We can get this type of information for the methane. Okay, not only for that, if you want to check for the other country, suppose I simply change the country name. Suppose I put here the country name, suppose Saudi Arabia. Just put here, click run. So now this layer is added for the Saudi Arabia. We can easily get the result for Saudi Arabia. And I also want to focus on the Saudi Arabia boundary. So for that, just use here map dot center object. Object is ry. Zoom level suppose 10. Click run. So now it directly focus on your given study area. You can see find out that look like that. So just try to stressing the data for get the more better visualization. Suppose I just stress the data in 98%. Now apply. So now you find out this type of result. We find out this type of result you can see. So basically this type of red color indicating about the high concentration of the methane. We can easily get it. As well as when you want to work for a specific, suppose you want to identify for rice field methane concentration, you want to monitor. So for that, first of all, you need to define the rice field, because sometimes we also need to monitor for the rice field methane concentration. And then for that, you can also apply the same process. But for that, first of all, you need to make the classification. Suppose you just make the land use land cover classification, and you can simply make the result for cropland or agricultural land or rice field. And then further, if you want, you can also monitor the rice field methane concentration. We can easily monitor. So this is the map about that methane. Okay. Suppose in this time, if you want, you can also work for the another data set. Suppose I want to work for the nitrogen dioxide. Same procedure also apply. Suppose if I show the example, suppose I want to work for this nitrogen dioxide. Click on here. So now we can get the nitrogen dioxide offline. Okay, because we find out the two types data, offline and near real time. And this is the data set, basically artisan snippet. So now I want to work with that. So just let me open a new code editor. Just paste here. Just copy the snippet ID and paste. Okay. Then give a variable name. Suppose I put the variable name is the data set equal. And now we also get the some band name. Here you can see. So one band name is that nitrogen column number density. Suppose you want to monitor where is the high density of the nitrogen dioxide, where is the low density of the nitrogen dioxide. You want to monitor. For that, we have to use the nitrogen column number density, this band. So just I simply copy this band and then apply the select function, select, and put this band name. And further, simply filter the specific date or a specific time. Suppose 2024, 1st January from 2024, 1st January from 31. So I take the data only for month of January. So now if I check how much images are available for that, so just print and call the data set, use the size function, and now run the code. So now we find out that 417 images are available for this dataset, mainly nitrogen dioxide dataset. So now if I just map dot add layer of this dataset, click to the run. So now it loaded the data for the whole world. We find out that whole world concentration of nitrogen dioxide. It look like that. You can see as a black color. But further, if you want to add the color, then you also get the whole world concentration. Because in this time, I have not used any kinds of specific boundary. So I want to suppose just copy their color code. You can see they also put some color code. And this unit is the mole per meter squared. Just a copy and then paste here. And copy this variable name. And this variable just add after the object name. So now run the code. So now this code is added. So now we find out that whole world result. Okay, between this time period, month of January, year of 2024, we find out that whole world nitrogen dioxide concentration map or density map. We can easily get it for the whole world. So, but in this case, I not need for the whole world. I need the data for a specific boundary or a specific polygon. Okay, so we can easily filter these things from here. Okay. So for that, if you want, you can simply import the boundary shapefile from the asset tab. Suppose I want to need the data for a specific country or any specific boundary, you can simply import your shapefile and then work with that. Suppose I just simply import the all of Africa country. Okay. And I put the variable name, suppose ROI. So now further, I need to clip with the ROI. So in this case, if I just use here the clip, just apply the clip with ROI, these things are not work. So you can see it show a problem. This problem is that it show the problem dataset clip is not a function because clip this function is only work for image. But in this case, this dataset is not the image. It's just an image collection. This image collection including total 417 images. So now these 417 images I need to convert into image. So that's why I need to apply the reducer. Suppose I take a variable. Suppose I put the variable name is that mean NO2 and then I call the image collection dataset and I apply for reducer, or you can also put the mean function directly. There is no problem. If you want, you can simply use the mean function, or if you want, you can simply put here the reduce. And how I can reduce? Art engine dot reducer dot mean. Anyone you can use. There is no problem. Okay. Suppose if you want, you can simply just use here the mean also. Also, there is no problem. Okay. And then I just click with my study area, which is ROI. So now we try to check the result. I want to add the layer for this final layer, average NO2. So now run the code. So now we find out this type of map of the whole Africa region. And if you want to check the more better visualization, so for that, just simply click on here. And you can see basically it's the sequence of color. So in this color, black is indicating very low concentration and red is very high. So this is sequence of color. I try to apply the tracing level. Just apply. Now you find out that type of visualization. So here you can see So basically this type of red color indicating about that not mass concentration, very less concentration of the nitrogen dioxide. And this type of red color, if you just simply increase, simply zoom. So this place is very high concentration about that, red color indicating about that. But other place you can see almost this type of things is not mass high concentration about that. We can also get some this place. This place is also high concentration. We can also find out. Or if you want, you can also check the other country also or any specific boundary. Simply import in here and also work with that. Suppose I want to import for the Dhaka city boundary. Just import Dhaka city boundary, and then further simply remove the previous one, and then apply here the just change the variable name as a ROI. So now run the code. So now it will be loaded for that your for the Dhaka city boundary. You can easily get the result. It look totally red color, but when you stress the data, you also get the more better visualization. So simply stressing the data. So just try to apply. So now from this, we can easily get the result. You can see we find out this type of result. So basically, this is the for this place we find out the high concentration of nitrogen dioxide for this type of place. Okay, red color indicating about that, and others basically this type of black color is not mass. If you want to check the inspector tab, just click on the inspector tab and click on this type of pixel. So now we can easily get this for this coordinate. What is the concentration? What is the density? What is the average density? We can easily find out in here. You can see 0.0031. This unit is the mole per meter square. Unit is the mole per meter square. Okay. Not only for that, for any study area, simply import your study area and also check about the result. What is the scenario of the nitrogen dioxide? You can easily get this result from here. Suppose I need the result for the whole country boundary of Bangladesh. Just I remove the previous one RY and I put this variable name as a ROI, and now run the code. So now this result, we find out the whole country boundary of Bangladesh in year of 2024, month of January. Okay, so you can see this is the whole country boundary of Bangladesh. And where we find out that this place, we find out that high concentration. Okay, we find out the high concentration of the nitrogen dioxide for this place. So we find out this type of map, and this is the result for year of 2024 month of January. So basically, you can find out this. This is the Dhaka city boundary. So in the Dhaka city, we find out that very high concentration of the nitrogen dioxide, because the main source of nitrogen dioxide resulting from human activities is the consumption of the fossil fuel, mainly coal, gas, and oil. Okay, especially fuel used in the car in the Dhaka city boundary. So that's why we find out that very high concentration of the nitrogen dioxide. Okay, and this thing it also produced from the making the nitric acid and welding and using the explosive, refining the petrol and metal, commercial manufacturing and food manufacturing. So there are a lot of activities. So due to the region, we find out the high density of the nitrogen dioxide in the Dhaka city. As well, also you can see this is the hill track area. Okay, so it's not mass. Okay, we can also get the in the port. Okay, in the port area, we also find out that the also some high concentration due to the fossil fuel. Okay, or burning the fuel. Another place we find out they're not mass. And this is the also, if I find out the some high also, also you can see from here, but other place it not much. So basically this is the scenario in month of January 2024. So if you check the other time period or other season or any specific time, simply change in here. So now I want to check the time series analysis. Suppose in year of 2024, month of January, when it will be high and when it will be low. Okay. So we can simply check our time series chart, and from this time series chart, we can easily get the result. We can easily get the result where the high temperature, where is the low temperature, when the low and when the high, we can easily get the specific time. So now I try to discuss about the time series chart, how we can easily make the time series chart for this data set. So we already discussed about that, how we can easily make the time series chart. So for that we use here UI dot chart dot image dot series. So this function mainly we use to create the time series chart. So now if I check all of argument one by one, just we find out that first argument is the image collection. Second argument is the region. Third argument is the reducer, then scale and X property. So now just make a dictionary. So curly bracket start and curly bracket end. The first argument, mainly keyword, is the image collection. So how much image you want to use to create this map? So in this case, we try to use here 417 images. So this is my image collection. And this image collection, I already stored in a variable. This variable name is the dataset. Okay, so I simply copy because dataset is stored 417 images. And further, I want to paste here, just paste here. And region, it's your shapefile variable name. So in this case, shapefile variable name is that RY, reducer. So in the reducer, I want to calculate, suppose, average concentration, average time series chart. So put here E dot reducer dot mean. Okay. Sometime you need the maximum concentration of nitrogen dioxide, then put here the max. You need the minimum concentration, then put here the mean. In this case, I want to calculate the average concentration. So just put here the mean. That scale. Scale is the resolution of your satellite imagery, 1113.2 meter. X property. So basically, I put here the X property. It's the default. We have to use system time start. So now this full thing just store it in a variable. Okay. Suppose I put the variable chart equal. So now this full thing is stored in the chart. If I just print the chart and click the run, so now it compute a chart. It takes some time because for the big study area, when you make the time series chart, it takes some time. Okay, so we find out this type of chart. Okay, and if you check the chart value, simply you can check it. So you can see we face a problem. This problem is that we find out that the chart show as a zero. It shows the null value. Okay, and you can check every point show as a null value. You can see it show the null value. Also you can show the null value. Okay, but these things how I can correct, but it has a value for each day. Basically we find out the daily base data for the 2nd January, then 3rd January, then also 3rd January for the another time, for 4th January we find out that for January 4th for the another time, 5th January, okay, 6th January, but all time it show me the data as a zero, because this data unit is the mole per meter square, and this data set we every single day we find out the very less value. So very less value show as a round figure zero. Okay, but when I convert the unit as a micromole, then we can find out the value. Okay, so now I need to convert the unit micromole per meter square. But in this case, if I just keep as a mole per meter square, then we find out a problem, because when I calculate using mole per meter square unit, this value is very less. Okay, so that's why it show the round figure as a zero. Okay, but when I convert the unit into mole to micromole, then we find out the value. Okay, so now we need to convert the unit, then we can easily get the result. Otherwise it show as a null value zero. Okay, every time show the null value zero. So now how I can convert this unit. So for converting this unit, I simply search here, suppose mole to micromole, simply search on the Google. So it show me the result. Look, you can see multiply the amount of substance value. So this value I need to multiply, then it convert into mole to micromole. Okay. So basically this result in my imagery, this is the result, or this data set, this unit is the mole. You can see this unit is the mole per meter square. Okay, so now this mole per meter square I need to convert into micromole per meter square. So then we got the result. And what is the equation? We need to multiply this value, need to multiply with mole result. So I already have mole result, so this result I simply multiply with this value, then it show me the proper value in micromole unit. So let's go. I will show you that how we can easily convert the unit mole to micromole, and further we create the time series chart. Otherwise, it shows a zero or null value. So let's go and discuss about that. So for creating these things, we need to create a function. Okay, we need to create a function. So this function we need to multiply with this value. So for that, I take a variable, suppose micromole, and I put the function keyword and the element name, suppose img, and I put the curly bracket. In this curly bracket I put my argument. So my argument is that this element or this image I want to multiply with the value. So for that, just use here the return function, return this image and multiply with this value. This value is that, simply copy 1 into 10 to the 6. Just I copy and paste the value in here. And now the same things I want to apply all of other images. So all of other images, just use here the copy properties and apply this image and apply these things into system time start to system time end. So this is the function. Okay, basically this function help you to convert the unit mole to micromole, and this is my collection. So I simply copy this data set and paste here. So I want to connecting, so I have a collection and I already create a function. So for the connecting, just paste here and then apply the map function. This map function mainly connecting the collection with your function. So this function now connecting with my data set, which is stored total 417 images. So now I just use this variable and make the time series chart. Copy and paste here and click run. So now it computed the time series chart in micromole unit. We find out the result in micromole unit. So now we find out the time series chart, and every we also get the value. So if you check it, there you can see we find out the value. So we find out the value for that 72.8 micromole. In this case, it the unit shows as a micromole, and we also find out the value 72.8. But previous time it showed as a 0 or null value because this unit was mole per meter square. But when I convert into micromole per meter square, then we can easily get the value. So you also face this type of problem, not only for these gases, also other gases. You show the 0 when you keep as a mole. Okay, so you try to convert into micromole, then you can easily get the value. So now you can see we can easily get the value. So 88.247 micromole in January 2021. So this is the average result because we calculated the time series as well. So now we also get the value for every time we get the value. Okay, but previous time if you keep only for the mole unit, then this result is not showing. Okay, because this is the process about that. For any other data set, when you make this type of part, you also, if you show the 0, then simply convert the unit. Suppose first time it show the mole unit, because when you calculate the mole unit, it show very less value. So that's why it show the round figure as a 0. But when you convert into micromole unit, then we also get the value. Okay? And from here, you can also download the data as a CSV file format. You can easily get the data from CSV format also. So this is the process about that. And further, if you check about the suppose trend, suppose not only for that, when you make the any data set, you want to check the trend. Suppose this trend is the high or this trend is the low. Okay, so you can also check the trend also from Google Earth Engine. So I will show the example for air quality data set, but you can also apply for any other data set. Suppose you want to make the NDVI time series chart or any other time series chart. So now you want to apply for a trend, okay, and check for the what is the trend. It is the high trend or low trend. We can easily get it from here. So let's go try to check about the trend. Okay, so let's go. I'll try to show the practically. So the same data set I want to use, and further I want to check about the trend. Okay, what is the trend about that? We want to check it. So for that, we already create this type of information. Right? So basically, this is the chart code. We already make the chart. And now for the chart, I want to check the trend. What is the trend of nitrogen dioxide in month of January? So basically, this time we just take the data only for the month of January. But if you want, you can also use any time period. Okay, for any specific time, summer season, rainy season, or anything, you can also try. The same procedure also apply. So now we talk about the trend and we try to apply for the trend. So for the trend, just write the code in here. Write in here. So just put here the trend lines. Okay. And then put the clone and then apply the bracket. In this bracket, just in this case, we find out the line. Mainly we find out the line graph only for the one. Okay. So in JavaScript program, we already know about the one is represented as the zero. Zero refers to the first item. So I want to make the time series chart of the trend chart for this line. So for that, just use at the zero. Zero refers to the only for the one, mainly first item or first line. And then I put here the all of parameter for this trend line. So first of all, type. So trend line type. So now we can use here the different types of type. Suppose linear trend line or a polynomial trend line or exponential trend line. But the different purpose we have to use different. So in this case, suppose I put here the linear. The linear. So now, okay, let me run the code and check what happened for that. Just a minute. Just a minute. I think, yeah. So this thing we have to write. Just you have to write after that. Just write in here. Okay, you have to set. Okay, sorry. We have to add the set options, and the set options we try to add everything. Okay. Suppose I want to add this. First of all, I just put here the chart title. Suppose I put the chart title. set options. Title, suppose NO2 time series. So now run the and check what happened. It working. So in the meantime, also try to add here for suppose vertical axis. Vertical axis, I put here vertical axis title. Suppose it show the value for micromole per meter square. Y level, and further I put here the suppose X axis title. Basically, it show about that time. Now we can easily set this type of information. Basically, X level I will title, and in this information we will also set about the another one. It's the trend line. Okay, so basically trend line we have to add under the set option function. Okay, previous time I add in the chart function, so that's why it not work. So after adding the set options, then we have to mention about the trend lines. So just I try to paste here trend line, and now you can see here this is another problem. We find out this type of problem. So now the chart we find out the line breaking chart. Okay, so to make the continuous chart, line breaking means that suppose some data are not fully fill up. Okay, some data are the missing in my data set. So that's why it shows the line breaking chart. Not only for the data, when you work with other data set, you also face this type of problem. So for solution about that, we have to use a function interpolation. So just I put here interpolate nulls and just apply at the true. Just call the interpolate nulls and I open it. Mainly I put the true. So now we find out the continuous chart. When you just open the interpolate nulls and apply the true, so then we find out the continuous chart. So when you face this type of problem for line breaking chart or chart is not continuous, so then you try to apply the interpolate nulls and apply the true. Okay. So now it's about the again continuous chart. Right. So now we have to apply for the trend about that. So just I call the trend lines and I want to just put the square bracket and then further 0 mainly only for the one line. So in this time we find out the only for the one line and I want to apply the chart type mainly linear. So if I just run the code, so now you find out that this type of line here you can see it show about the line. So basically it show about the uptrend. Uptrend mainly day by day for this study area for Bangladesh. We find out that this data set is the high trend. It means that day by day increase the density, increase the nitrogen dioxide pollution. So further, if you want, you can also add the some style about that. Suppose I put at the linear, but then if you add the more style for your chart, for the trend line chart, it was possible. Suppose I want to add the color. Okay, for this line, I want to add a color. So for that, just put the trend line color. So put here the color, and I put the color as a suppose red color. Just click the run. So now this trend line color show as a red color. And this type of things you can also apply for any kinds of time series chart. Okay, for NDVI trend or NWI trend or EVI trend. So any time series chart, just apply the same process for adding the chart title, Y level title, X level title, as well also adding the trend line. Okay, so suppose in this case I also want to increase the line width. Okay, line width I want to increase. So for that, just put here that line width. I put here suppose 3 pixel, 3. So now we find out this line is also we find out the width. This line width is also increased. So you can see this line is also increased. The weight is increased. Line weight is increased. Further, if you want, you can also decrease the opacity. Suppose you set the opacity of this line. So further, just use here the opacity. Put here the opacity. Suppose I put the opacity is the 0.2. So now run the code. Okay, you can see now it also opacity. Okay, we find out the 0.2. You can also increasing. Then it also more opacity is also increased about the chart. Or as well as you also add the legend. Suppose trend line legend. We also add the legend also. So for that, just write here the visible in legend. So visible in legend. Just put here the true. So now it also added the legend for this time series chart and the trend chart. So now I can see about the legend also. Just I click on here. So it show about that this type of legend also get from here. Okay, it show the legend. You can see this is the trend legend and this is the chart. Okay, chart line. Just added the legend about that. Not only for that, if you want, you can also add here the chart area background color. Suppose you want to change the background color. So for that, just write the code in here. Just write the code in here. Suppose I put here the new a thing, suppose chart area, and these things I want to add the background color. So just I put here the background color. So just put here background color, and I put any color you can mention in here. Suppose I put here the color. Suppose I put here the color for this one. Suppose put them. I put it suppose yellow color. You can put any color. So put here the so I think some problem in here. It show the unexpected token. Okay, 45 we mistake in here. right in here. Suppose I put here another argument chart. Mhm. And right here the background color. As I put here the color is that hue. It show the okay. I think suppose I put at the one hexacode. Suppose I simply search on the Google yellow color hexacode. ND background. Okay, so now I can get this type of chart. You can see it show the yellow color. Okay. So try to put the more better color. Which color is also more better for your chart. So this is the process. You can simply edit the color. Which color is more better for your chart? You can also try to add it and also edit. As well as if you want, you can also change the. You can simply remove all of grid line color. Suppose you can see we can find out the grid. So this type of vertical and horizontal grid we find out this type of grid color. So if you want, you can also change this type of color, or if you want, you can also remove all of grid color. Suppose I want to remove the grid color for vertical and horizontal. So for that, you can simply write some other argument. Suppose after the title, I want to add another thing is that this one is for the grid line. Suppose I put at the grid lines, grid lines, and I apply the count as a 0. Okay. So now vertical, mainly Y level grid will be removed. If I run the code, you can see Y level, there is no grid. You can see there is no uh, grid. Okay, suppose I put at the vertical axis. So just I put at the grid lines, put at the count 0. So now it will be remove all of grid line. For X level, Y level, both of grid are removed. So when I put the count 0, so I can see now the chart there is no grid line for X level, Y level, there is no grid. Okay, just it show this type of blank. So you also try to add or edit this type of code and also add the more other chart also. So now this is a process about that for working with this type of data and also make the time series chart as well, also check the trend for this type of data. So now any question about that you can ask me. Any question? Any question please? Okay, I hope there is no question. So now we talk about that, and you also try for the other data set also because it's provides a lot of data, such as we can easily get for nitrogen oxide, ozone, or also sulfur methane or sulfur dioxide. Okay, also you can see the formaldehyde, carbon monoxide. So this type of data you also try, and further you also check the or make creating the map and also check the time series chart about that. So now we talk about that how we can easily work with PM 2.5, mainly particulate matter 2.5, how we can easily work with that. So it's very important gases. PM 2.5 also try to stress using Google Earth Engine using remote sensing technique. If I simply search here PM, suppose PM 2.5, convert PM, convert AOD to PM 2.5. I simply search. So basically in this case, we try to apply the method basically from AOD. From AOD, we try to calculate the PM 2.5. Okay. So basically AOD is the aerosol optical depth data. Okay. So if you check it for the converting AOD to PM 2.5 statistical approach. So from this PDF, we can easily get this idea how we can easily work with AOD to PM 2.5. Okay. So basically in this, you can see the objective convert satellite drive aerosol optical depth into surface level PM 2.5. Okay. Concentrating using a statistical approach. In this time we are using here. So in this method, basically we need the data, record data we need for the PM 2.5 mass concentration from the ground monitor. Okay. So first of all, you need the data in the ground. We need the ground data. When you want to work for that PM 2.5, we need some ground truth data. Okay, this is the one requirement data. Second data, we need the satellite drive aerosol optical depth. Okay, we need the data from satellite. Mainly, we can easily find out the MODIS AOD data. We can easily get from the satellite. As well as meteorological field data, only if working with the multivariable method. It's not mandatory. So basically, we need the ground truth data as well as we also need the satellite drive aerosol optical depth data. So this data, satellite AOD data or aerosol optical data, we can easily get from our Google Earth Engine data catalog. So basically, if I simply search here, suppose AOD, simply search aerosol optical depth or AOD, we can easily get the one data. You can see this is the data set. This data set provide you the aerosol optical depth daily. We can find out the daily data, and this resolution is the 1 kilometer. Okay. So this data we can easily get from AOD or aerosol optical depth. So from this data, we can easily get the optical depth, mainly 0.47 micrometer. We can get that data from here. So this data we can easily get from satellite drive aerosol optical depth, and this data is the globally available. We can easily get it. But when you want to work the PM 2.5 concentration, we need the PM 2.5 ground data. It's very important. We need the ground data. Not only for that, when you check the accuracy for any map, suppose here you can see, I already create the two map, one map for the methane, another map for that nitrogen dioxide. So now I want to check what the accuracy of this map. So for checking the accuracy, you must need the ground level data. Okay. So we can easily, we need the ground truth data for this checking the accuracy about this map. As well as we already created the map for methane. We already created the map for methane. So now what's the accuracy about this map? So checking this accuracy, you must need the ground truth data. Okay. So then we just compare. Okay. We compare using different method, suppose RMSE, or we can also find out the R square value or correlation between the satellite data and also ground data. Suppose we can say RMSE, we can easily apply the RMSE formula. We can easily use the formula. This is the RMSE formula. So we can easily apply this type of formula, and further we can easily calculate the accuracy from ground data and satellite data. So satellite data we can easily get from Sentinel-5P. Suppose this data I can easily get from the Sentinel-5 period, I can easily get it from the satellite. And when you have the ground data, then you can easily apply this formula RMSE, root mean square error, and then we can easily check the accuracy. Okay. So basically, when you want to check the accuracy, we must need the data. Mainly, we need the ground data, and also need about the satellite data. So satellite data we can easily get from the satellite, but when you want to need the ground data, so basically we are using the different types of instrument to get the ground data for different gases, such as PM 2.5 or nitrogen dioxide or sulfur dioxide. We are using the different types of instrument, and then we collect the data, also their GPS location. Okay, and further we can simply extract the same information from this satellite imagery also. So further I'll also show you that how we can easily extract the value from satellite data and also work with, then you can easily get the idea. So we find out this type, you can see we need the data PM 2.5 from ground and also need the data from satellite. Okay. So now this paper is also mentioned some data. So we find out the correlation. So correlation, suppose you can see this is the location point they are finding here. So this is the location point getting their data, and they are find out this type of color 0 to 0.25 correlation, mainly R value. Then this type of, so it also have some value, okay, for their study area. Okay, so further they are calculate the correlation. Okay, you can see here, and they're converting the AOD to PM 2.5. So we can easily get, there also put some layers that you can see. We can easily get the MODIS AOD data file from NASA data server for your region, date and time of interest. You can simply go to this, then you can randomly download the data from the NASA data server for the MODIS AOD. We can easily get it from here. And they also provide some information you can see to get the PM 2.5 for your own region. For the United States, we are just simply go to this link and we can easily get the data for PM 2.5 for United States or global air quality monitoring system. It also provides the globally, and global open data we can also get it, and your own data source or measurement. Suppose you can simply visit it with your instrument and you also just collect the data. Okay. So further you also check this type of link for your own data. You try to check, and now we need the converting the AOD to PM 2.5. So basically, we are using the Python or Matplotlib, this type of code to obtain the AOD data at the location of the PM 2.5 ground data monitor. So they also provide some this type of Python script or code editor. So further, let's check. And I already developed this type of code with the practical example. So I'll show you the for that how we can easily get this type of data and how we can easily create this type of things. I'll show you that. Okay, so now, okay, after doing these things, after getting the data, so mainly they are calculating the converting AOD and they are find out this type of equation here you can see. So mainly they are calculate the y equal to mx plus c, mainly linear equation they are calculate y equal to mx plus c. So here x is independent variable, y is dependent variable. So they are calculated PM 2.5 equal to mx plus c. Here m mainly slope value, x mainly AOD value, plus c mainly intercept value, and they also calculate the correlation, mainly R square value they are also calculated. So this column is the PM 2.5 and this column is the aerosol optical depth. Okay, so aerosol optical depth we find out from satellite data, and PM 2.5 we find out in the ground data. Okay, and then we can make this type of things. So these things we can easily do using the Excel file as well as also use the Python programming. This type of correlation where I told mx plus you can easily generate. And now we find out this type of equation. So when I apply this type of equation, then we can easily get the result for PM 2.5. Okay, so for that we need the ground truth data, and using the ground truth data we can simply create the linear equation y equal to mx plus c. Then we can get this type of equation. This type of equation basically we find out the slope value, and also we find out that your intercept value, mainly m value and c value. So then we can easily apply the equation, and then we can calculate it the PM 2.5. So this is the statistical approach, and convert Moody's AOD to PM 2.5. Okay. Also, you can see they are provide some information for that good 0 to 50. This is the good, moderate 51 to 100, unhealthy for sensitive. So they are make some classes. Okay, and make this type of things. So let's go practically discuss about that how we can easily do this type of process. So first of all, I need the data for Moody's AOD. So if you check the Moody's AOD dataset, where is it? This dataset. Okay. So first of all, I want to work with this dataset, and then we convert the AOD to PM 2.5. So let's go. Just open a new code editor.